Awesome. All right. Good evening, everybody. I'm Dave Perrill, and I'm CEO of Compute North. And I'm here to talk to you today about how we see mining innovation moving its way to the mainstream data center. So quick introduction to Compute North. We're focused on infrastructure, development solutions for miners and any type of high-performance computing. We're headquartered in Minneapolis, so we don't get a lot of visitors in January. We have operations in 3 states. And we think what makes us different is we work very diligently to be trusted and credible, drive our costs out of everything that we do, and ultimately move with a sense of urgency and speed to take care of our clients. Data centers, modern data centers today are pretty awesome. There's no question about it. These huge buildings don't have any single point of failure, and from an end user standpoint, they simply work. And that's because everything's redundant. The fiber, the electrical, the cooling, everything that makes these systems work, and that really is the promise of the cloud. It is that you can launch an application, and they simply function, and they simply work for the end user. But they come at an extremely high cost. Again, for miners in this room, the cost of the data centers probably blow your mind. For a Tier 4 data center, $7 to $12 million per megawatt. And to make matters worse, for every dollar you're spending on energy for the actual computing infrastructure, you're spending 80 to another 100% on ancillary systems, mechanical cooling, other types of subsystems to run the environment. Operating expense is very expensive as well, and you're looking at over 2 years to get these types of systems online. And I think the question needs to be asked is, do all applications require this level of redundancy and reliability? And this guy did not think so. For those of you who don't recognize him, this is Sean Fanning, the inventor of Napster. And one of the reasons I had some really great music in my parties back in the dorm room days back in college, because you could simply click, search for music, download it from anywhere on the web, and there was no centralized control. Eventually, as you all know, the story, it did get shut down, but it was a massive success from a peer-to-peer standpoint. And crypto and blockchain, I think, share a lot of these similar characteristics, but they also have a few things that are unique. And specifically, again, the miners in this room know this. These systems run on specialized hardware. ASICs aren't something you're going to find in your office. You're not going to find it at your home. You're not going to find it, around a standard computing environment. Secondly, as many of the speakers alluded to here, this thing is going to industrial scale. The size and scale of the mining industry has reached different heights than it was even 18 months ago. And then third, you got to be really smart about your costs. In order to work through the winters, in order to make this type of environment work, you got to be pushing out costs in everything that you do. And data centers today, as they're built, don't work for this. First and foremost, their economics don't make sense. Both the CapEx, the PUE, everything that goes into operating these simply doesn't align. Secondly, the density that we support, 30 kW or even greater, it just doesn't work as well. They're used to much less dense loads for their computing infrastructure to make it work. And then third, a lot of these big REITs, a lot of these big data center operators simply won't underwrite crypto. When they ultimately see what we do and the underlying credit risk is something they're not willing to get involved in. So we are proposing, and what we're starting to see is the innovation in what we consider the Tier 0 data center. Our data centers today are classified into 1 of 4 categories. Tier 1 through Tier 4. The higher that you go up in the tier level, the more redundancy, the more infrastructure, the more reliability that gets put in place, but also the costs. And what miners and a lot of the folks in this room are building today are much more of a best effort type scenario. And that's, again, the Tier 0, where we see cost being the name of the game, much more versus the redundancy. This turns it into much more of a best effort type scenario where you're trying to get the computing done in a best effort scenario versus absolutely guarantee it's going to happen. Energy, which is 80% of our operational costs, we're going to the source versus the other way around, and we're doing everything we can to minimize the PUE and any type of excess in operations costs. So not using external cooling, not using anything other than maybe immersion, but being very smart about additional costs that go into our energy. And this ultimately drives to how do we make the applications redundant so they can support this type of environment. And again, the miners in this room will recognize a lot of these slides, but the economics here, that the capital expenditure is about 3% of a Tier 4 data center, 150K to 250K per megawatt. Power usage, under 5%. So again, if you're spending $1 on your energy, there's only a small fraction that's going to ancillary systems, which aren't value add. Operating expenses are much less, and once again, the people in this room know this, you can get these things online in a much quicker time frame. So where we see the convergence points where this is coming together, blockchain and proof of work are obviously already here. And that's kind of the big use case today. But how does this evolve? And we see several projects on the horizon that we're keeping track of and are very interested in, particularly around machine and deep learning. I didn't put AI. I think that's a little bit far out today for what we're looking here. But the need to do high levels of deep learning and training for these algorithms and these AI subsystems, very computationally intensive, need to be necessarily in a mission critical world, but can be done in a best effort scenario, make a lot of sense. 06 and NVIDIA, we've seen some really interesting projects there. Graphic rendering, being able to produce your movies or whatever types of videos in the web, also makes a lot of sense. And then grid computing, with Definity kind of leading the lead there. Storage and Saya are one of our partners, also very interesting projects. So, what I want to leave you with here today is 4 things, is that modern data centers have incredible amounts of waste, unquestionably so. I'm always humbled by how many smart and intelligent people there are in this industry doing some really cool things and doing more with less. It's always impressive. And I think that there's applications that are being designed that don't require the level of scale and redundancy that we see today in the modern data center. And I think the Tier 0 data center is poised to change much of the ecosystem as it exists. So we're excited for the future. Thank you for your time. Hope to see many of you at the rest of the cocktail hour tonight. So thank you.